That seems to work easiest for me.
Okay, recording.
Great. Okay. Welcome everyone to our education session for Tuesday, July 14th. And Tomislav, go ahead and what's on the agenda for today?
Okay. So for today, I would like to talk about the simple implementation of Rholang that I posted last time. So this is like a continuation, but a version that is much nicer, and it shows better how this state and the operations are separated. So do you see my screen?
Yes.
Okay. So in this Rholang implementation, we don't have all of the normal stuff that we are used to in normal Rholang. So the only thing that we have is really a par operation, or maybe better to show the operations first. We have nil as the empty process. We have par to combine two processes, and we have a very simple send and receive, which you can just specify the channel. So it's totally simple without any values, and you're just specifying the channel, and channel can be only the string. So that's the whole language that we have. This is why it's simple. So this is operations in our language, and another part of what we are doing in the background, we are modifying some state. So with these operations, how we combine these operations, state will be changed in different way. And this is something that I want to point out or show how basically defining functions which operate on the state are definitions of our language. So this is why we have some kind of encoding. We first say we will operate all of our terms in our language, like all of our basic rules, we will call process. So everything in our language we will call process. This is like little box that every time when we write something, we have this process. And this process is what we see in operations. So each of our operations returns process. So nil returns process, which has a meaning of empty process. Par accepts two processes and again returns a process. Send again returns the process. It's accepting a string as a channel. Receive, it's basically looks the same. Accepts a string and again returns the process. And this is why when we have different, our operations are always returning process. So now we want to represent our state as a different variation of this process. So I created these three classes, which each of them extend process and represents different state. Different state that this class holds. And all of these classes are private, which means that in our object Rholang, these classes will be visible. And this is on purpose, because I want to show that from outside, we only see our basic interface without ability to inspect the state. So we only see process, and we only see these four operations. And this is the only way that we can interact with our language. And we can think this in a way how we have unforgeable names in Rholang, right? Inside Rholang language, you cannot access some specific unforgeable name. You cannot say, oh, I want to change this unforgeable name. So in the same way, here we have this state isolated, so it's invisible from the users who are using this mini language. Is this so far make sense?
Yes, it makes sense to me.
Cool. So now the question is, what we want to do when we are combining our operations. So let's first see how can we use our language, what we defined, because we have this these 4 functions. So here, first I just defined a special name for par. So instead of writing par P1, P2, these 2 processes, I defined this pipe as a alias for par. And this is nice that we can do this in Scala, so we can write functions like this. But its syntax is a little strange because we need to define this implicit class, which has only 1 argument on which we are extending this function, which implementation is here. So, either way, we can do it in Scala. So this is like nice that this works. So we have these 4 functions, and par, we have alias for par. So we can write par as a infix function in between. And we can think about this function in the same way how we have plus when we are doing like simple algebra with numbers, right? 1 plus 2, 1 plus 2 plus 3. We don't need to recalculate how functions are called, right? We can just say that if we have this kind of expression, P1, par P2, P3, we just have par P1, P2, and then we have another, for example. So this is a replacement for this expression. Does this make sense? We are just combining first 2 elements, and after that this becomes argument to the first, and then we are we are supplying the second to the second part. And this is like a shorter notation, and this is why we want to use it.
Right. Okay.
So now this is our use of this language that we defined. So we created some expressions. So we are just calling these functions that we have, these operations, these 4 operations that we have, and we are creating the processes with these functions. So each of these variables are process, because I showed that each of our operation return process. So we don't have anything else. We have process. We cannot say, oh, is this a send or par? When we call this function, we only have process. And then we can combine all of these processes with the par, because we have so simple languages, we cannot do anything else. We cannot receive and continue on something like we have in normal Rholang. We can only say that we are receiving, but nothing will happen. so it's very simple. And we can evaluate our language. So let's now go back. So now we see how can we use it, and so we can have, even in Scala, we can have some nice way how can we combine this, because exactly this pipe is our append operation from Monoid, and nil is empty operation. So we have this Monoid created by nil and par as an empty and append. You can recognize that this is a binary function which accepts two elements of this type and return the same type. This is basically a monoid operation. Is this make sense so far? I don't want to go too far.
I think for the parts that we may not necessarily understand, we can always go back and watch the video a second time. So I don't want to interrupt your flow. You keep pressing ahead.
No, please. If you have any question, yeah, I would like to answer before I go further. When I was talking about monoid, I said that monoid has these two operations that we need to satisfy. Oops. If you remember from semigroup, which extends monoid, we have combine, and with monoid itself we get the empty. So now here we have this situation. We have nil, which so our process is here A. So we have concrete type. So when we call nil, function nil, we will get this empty, what in our case represents empty state. Like not even empty state. We are just saying we have this element in our language which is completely neutral, right? Because combining nil with anything else doesn't change anything. And I will show you this in our interpreter, because in our interpreter we must obey this rule, so that we can say, oh, this is really a monoid, because we are obeying these rules. And these rules are, for example, specified here. And I will show where these rules are implemented here. And another operation is combine. And this is our par. We have something of type A and another element of type A, and we are returning A. So we have the same here. We have one process, another process, and we are returning the process. So it's just just by looking at the syntax and the signature of this function, which types are input and output, we are saying, oh, this really looks like a monoid, but we need to obey some laws. So we can say, oh, we really have a monoid with these two operations.
Okay, yeah, I'm following that.
And for send and receive, we really don't have anything to say, oh, this is part of something, right? We just say, oh, we have these additional two operations. We are not saying anything what is the meaning of that. I mean, we are saying something. We are calling this send or receive. So we definitely want to say something, but just from the signature, they are not telling us anything additional. So now the question is, what is the real the body of these functions, right? What these functions are returning? So for nil, so now I must say what is the representation of our state, right? Until now I didn't say anything about our state. I just said we have process which is a trait with anything inside. So it's just an empty interface. It doesn't say anything. It's, you know, and I explained like what we have as our language. I explained how can we use it. So this is really what we mean by abstraction. We want to isolate the whole meaning and the usage of our language without ever saying what is the underlying state, right? So we are developing our sentences in our language. We can assign different meaning, but we still didn't say really how our language is implemented. And this is nice because we can start programming just with interface, just with operations that we create. We don't need to implement the whole language. Or from another perspective, we can create very simple implementations like we are doing now, and you know, in the later time we can implement like the full language or all the features that we want. So we can create a mock implementation for example for tests, and this is exactly what usually we are doing in tests. Now I will show you how we want to represent state. So now the question is the state, the real thing, where the magic is happening, because we need to store this somehow. You know, we need to use memory to really evaluate our language and keep all of the variables and all of the names or whatever we have. And the state is also very simple in this example. We are storing state in. So first we have three different classes that represents how we want to manage or create this process that holds the state. And we want to have something simple because these classes are basically just some kind of way to collect information, how our users of our language are combining these different operations. If I'm not sure if this makes sense, what I want to say. We somehow want to connect these operations to some our state that we are developing, right? So for example, for nil, we could create another class here, right? You can say, oh, but you don't have nil. Yeah, we can create like nil, which doesn't do anything, right? And then we can encode this in some way, but we can also think differently and say, yeah, but nil is really we can represent nil with our par class, but this state that we have inside par, we will just use empty set, because this is a syntax for default value. So this means that if I call par without anything for this parameter s, this will mean that this set will be set to default and this will be empty. So what we are saying is, well, nil doesn't deserve special class because this is just an empty par with empty state. So basically we are just thinking what this operation in our language, what is doing to the state, what represents in our state. So, and this is how we are start with implementation. And this doesn't mean only for when we are developing language. We can develop some other feature in our application, right? We can develop some like retrieving blocks from other nodes or this kind of operations. This is also like a mini language that we want to create or control. So, and then how we design these classes. This is really part of how we really want. Maybe there is no there is a from scratch. This is not always obvious in which way we want to or what is the shape of our state. So when Greg is saying that with a ladle, this state is nice, that is some kind of set like, or multi-set, or even topos, whatever topos means, I'm not sure, but this is even more complicated state. So I want to say that basically everything depends on the structure of our state. So we can start from a simple set, and we can think about for the next session, oh, maybe it would be nice if we can use a multi-set or two sets, or some kind of additional state that can give us more features for our language. Is this make sense? How state is something that we are modeling, right, inside.
Tomislav, is there any way that we could get some maybe example, very simple examples to visualize it? What you're saying? That I mean, my thought is that maybe it might be, so like start from very elementary hello world, and then keep adding to that, and help sort of like provide more additional, maybe go back and forth between what you're doing here, talking about the definition of the language, and then saying, okay, well, here's a very simple example of this lesson.
When you say visualize, which part would be helpful for you? On which part you're thinking more specifically?
I mean, at least for me, I'm not sure about others on the call, but for me, I mean, I don't have a lot of context on and the background on some of the topics that you're going over, and I guess maybe the old style learning of just actually watching and looking at a working example to see how moving all the things which are moving to get a feel for. So what I'm just saying is that you're just explaining about combining operations and states. If there is any way to visualize that lesson in an example, saying here's a list of ABC, and here is a list is XYZ, and we need to combine them. This is what we need to do. So sort of like give a more of a actual example of what you're just describing here.
So you're saying if I execute something in this language and start from there, that would be useful.
Just you're describing. So for me, as I said, I maybe I don't have enough context. That's why some of this stuff is not sinking in. And if I'm able to, it's like I think somebody said it's monkey see, monkey do, right? I can look at an example of a very small contained example of what you're describing, and then I can extrapolate from that and make my own changes and play with it, compile it, make more changes, see where so if I understand that whole concept. So that's where I was coming from when I said visualize.
Okay, cool. I have exactly that. So yeah, I was not sure, you know, from which side is better. So we can definitely go, you know, execute something, and then we can take a look what is the state and see how this behaves. So let's delete all.
Yeah,
of
I mean,
this.
I certainly understand that slows things down. I mean, but you know, I'm not sure how. But at least for me, I don't know the others on the call. So I mean, I can come back another time and have that more detailed discussion with you if others are okay with it. What the way you're presenting right now.
Let's see. I'm definitely for that. You know, we look from the final point, and then, you know, we go back, and then again we look some results, and then go back. So yeah. So let's execute some code, because this is a working example, and the idea is that you can easily just take this file, and it will work without any dependency, because there is no dependency. You can just execute this in some kind of online Scala REPL or some interpreter. So let's execute some programs. So, for example, we can have just simple, our program can be just one simple, one operation in our language. And what is the result of this one operation? Is a process, right? I said everything is a process, because send is returning a process. This is the definition. And when we execute this function, we will just get this send class as the result. But we don't see it from this point. We only see the process, right? We see the interface. This is how in object-oriented language you usually want to work with. I mean in C also, you're working with interfaces, not with a specific class. So this just is the same thing. We are working with functions which are returning interface, but really classes are in the background. For classes are in our memory. Is this make sense? So this function send returns instance of our send class here, because this is our constructor.
Right.
So to create this send instance, in Java you would write something like that, but in Scala this is not necessary. For case classes this is not necessary, so we don't need to specify new, and we are just returning send.
So if I may just drill a little bit further down, and you may have covered this in the previous sessions. So when you say send, you're sending a message A to someone, or who are you sending the message to? Is it a state machine?
Good question. For now, I'm not saying anything. I'm just creating a class send and returning. Nothing else. No, any communication is not involved. Nothing is involved. Totally nothing. Just creating a class, calling a constructor and creating a class.
Okay.
So yeah, it's definitely simpler than you think. So all of our operations. So I can create another program, and I can say, oh, but I have a receive in par with send on A. So now we will create a receive class, we will create send class, and we will supply these two classes to our par function. So we don't know what our power function implementation is doing for now. So for now, we know that receive will create a receive class and send class. So when I execute this, the only thing that is happening is something with the par. And now we can see what par is doing in our language. It will collect left side and right side in the set and return our par class. So let's go. So now let's go back to our par implementation, right? And now we can see, oh, I have two processes and I have a pattern matching on different classes, right? So we want to know, what are you sending to me, right? Which of these classes are in this par? So because we will do different things. This is our main thing in our language, this par. And this is very similar in Rholang. So all of these first cases are not relevant for our case because they are involving par class or on both arguments or at least one. So we will not talk about this right now, but we will say, oh, this is what is executed, because we don't care about what is here. Is it send or receive or two receives, two sends? What we are going to do is create par class in the same way how we are creating send. We are just calling constructor. And we will combine in set our two processes that we are supplying. And we know that this must be send or receive, in some combination. And we are not doing anything. We are just taking these two arguments, putting in the set, and creating par class. That's it. Done. No external calls, no anything. We're just taking these two arguments and putting it in the set, because these two arguments are processes. Does this make sense?
Yep, that got it. Got that part. Yep, thank you.
So we are playing with classes, right? We extended process in 3 different classes. And now where someone give us these classes, we are matching. Oh, do I have send? Do I have receive? Do I have par? And we are deciding what we want to do with this information that we have in constructor. With case classes, we can directly match to our constructors. So this expression really means extract, match par in this first position, and extract the s as this variable s1. So we are matching directly the constructor. In the same way we are calling constructor, we are matching constructor on the left side. So we are saying, oh, I'm extracting the value what is supplied inside in this constructor when this class was created. Okay. Okay.
Yep, got it. Thank you.
So now, so now basically we have we can see what our other cases really means. So if we supply, so now we have par, right? A prog tree is really a par. So we can write. So let's first write some simpler case. So very simple case. Send something in par with nil. So now again we are using the same case here will be executed. So send will be here and nil will be here, and combining these two, we will get the result. let's see. Okay. So let's see the result. What is the result? But I'm not saying this correctly because yeah. Okay, let's go to this together. How what situation we have now? So first argument is will be our send class, and the second argument will be whatever nil returns. So send and whatever nil returns. And when we go back here in our par implementation, now we can say, okay, first is a send. So it's not this one, because this must be par. It's not this one, because must be par, but maybe it's this one, right? So we are matching in sequence each case. So can this case be matched? So first is okay. So this means we can match for any process that is supplied, and we will have this process as a variable. But the second one must be par. And this is interesting because nil will return par, right? So what we will have here when we are matching this empty par, what is going to be S2? And S2 is really this thing here. So we are extracting S2 from empty par. Right? So here you can imagine that someone created something like this, and this is empty set, right? So this way defining the default parameter gives us a way to not specify here nothing, and we will have the same meaning as this. So just by looking at the syntax, how we are matching classes and arguments, we know what is the S2 represents. It represents this set, right? And this set will be empty. So now that we are combining whatever process we have here, and this process is not par, because we know that it's not par. We try to match it first. We will just combine these two things. We will take whatever set we have here, we will add, this plus is append. We will append, we will add another element to this set. So in case of nil, this S2 will be empty, right? Because it's created here as an empty set. And P2, whatever we have, we will add to this empty set. And this is our interpretation if someone gives us a send or receive with the par. And we have two cases here to cover, you know, on both sides, right? We want to cover this from nil here. Oh, let's write both cases. So we have similar situation, but nil on the left side. Let's execute this. And this is what we have. We have, as a result, we have par with a set inside which has only one element, this send that we created here. So basically we said, yes, we have a proof that our par operation with nil really is a monoid, because nil on the right side, nil on the left side will change nothing. And this is the same as just using a send. So all of these things is very, very simple. Creating classes, matching on the data that this class holds, and just, you know, combining this in our state, which is the set. So we are appending our elements to the set, and this is the whole story that you know this represents.
Very good. Thank you, Tomislav.
Do you see this these classes and how we really want to use the state? I'm waiting if if someone has some question or you know.
Just want to confirm that line 105 is same as 99, correct? I mean, you're not trying to
Exactly.
just say, okay, all right.
But I will prove it to you. Prog 2 equal to 6. So this is something that you usually don't have in Java or C#. This is very specific to case classes. They can be structurally compared for equivalence. So these things are the same structure, right? So we can compare it with equals, and we will get yes, they are completely equal. And not only that, we can say, yeah, but this is equal to prog 4, and this is equal to prog 5. But I must do something like that, or well, this will not work. Yeah, equal doesn't behave in a way that I would like.
I'm assuming one is a set, the others are not, right?
All of these things are processes, but the equals is not equal returns true false. So basically, I need to repeat all of these things. So I need to say this is equal, and then maybe like this. I can say yeah. Just to collect in the one tuple. So we are comparing prog 2 with prog 6, and then prog 6 with prog 4. So if both are true, then prog 2 is equal to prog 4, and this should be the case. Oh, prog 6 is not equal to prog 4.
One is a you have it as a set, right? The other one is
yeah. So basically, this is I can say this is some kind of bug, or because this should be the same, right? If you write send nil and just send, I just explained that this is the same thing, and now I'm saying, oh, this is not the same. So I'm lying, right? So I need to fix this. So to be correct, I should implement this in this way. I should say, oh, but this is par with one element of this set. This should be the correct implementation if I want to be correct, right? I should put this in a par and not just receive the class itself. So now we will have correct implementation. Now it's okay, right? So every time we are calling send and receive, we will package up this in a par.
Tomislav, what happens if you have like let's just take instead of nil, let's look at either line 103 or 104. Instead of nil, you have the same. If you do a send name of A, if you have both of them are same entry, what is the outcome of that?
So you're interested in
like proc7. Let's say proc7 is equal to send name A
and another send.
And another send name A, yeah.
Send A, or you want something else?
Just keep that A. Yeah, what is the outcome of this?
Mm-hmm. So you're basically probing what our language is doing, right? You want to see, oh, how this language is working. And
right.
You see here, oh, you have only one send. So, and this makes sense in our language because we cannot detect this. We have only set of processes, and we are collecting processes in our in this one set that we have. So if we are if we have two sends on the same channel with the same this argument name, they will be the same, right? Because they are structurally equal. They are the same class with the same argument, so they are the same. And this means when we are doing this operation of union, we will just lose information if we have two sends that are the same. And this is why we want to use more complicated structure here for the state. We can use multiset, because in multiset, we can record how many sends do we have. And this is exactly how Rholang is working. Because if we have multiple sends in our Rholang specified, we know that you know they will be preserved. And if we have multiple receives, they will be matched together. We will not lose some kind of, you know, in some way, these duplicated processes that are completely the same. Is this make sense? How now
yep.
we are pushing everything to our state, right? We are creating this par class. This par class is like more important than these two classes, right? These two classes are just, you know, oh, I have this string parameter, but this par are some kind of the whole state. So even if we have two pars, we will create another par where we will push everything inside. So, and this is why at the end we always get par, right?
Correct.
Because par is our state. So we are you know, we are building this giant par. You're giving one par, small par, and you know, I just take the set from inside and put together with this other one, and now I say, oh, I have a bigger par, you know. And this is how Rholang is working also. Our program that we are deploying is our par, and the whole tuple space in our node is another par, and we are just pairing these two things together and combining in the larger par and storing back to the R node tuple space. But basically, we are doing the same thing. We are combining this par operation.
So I don't mean to throw off, you know, what you have already planned. Like you know what you had a set of instructions that you were going to go through. So I don't want to so you know take you off that path. But maybe next week, or if you think that's maybe too early, we could possibly use a one practical example. Let's just take example of sending transactions that we do today, rev transaction, right? The contract that we have for that. Could we use that as an example and maybe just take each statement and then drill down and say, okay, how and what, you know, as detailed as you are going through this part? Is that something possible?
You mean in the real source code or 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 you think about some kind of very simple example, or?
Yeah. Remember, or as earlier as I said, for me at least, looking at something practical example, in a sense, helps to visualize what's happening under the hood as well. So maybe use an example, something that we're all are very familiar with, and then drill that down and say, okay, this is how it's implemented under the hood, and then this is what's happening with the language around that. So I don't know, just that's maybe that's my way of learning things. But I thought that might be somewhat of a feedback that you might want to incorporate in your future lesson.
Yeah, this is pretty complicated example. So I wanted to go from this simple stuff and just build from there, because this is like more complicated example, but the principles are the same. So maybe so now you can ask, but what is the purpose of this, right? We are creating classes and combining states. Okay, the purpose is this eval operation, and this is, we are running our program. So now what I showed you here is we are just combining our expressions in our language, right? You write your program, we parse the code, and now we combine all of this in this giant set, right? And now the question is, but how you execute your program? And this is what you are asking. How can we produce some result? How can we make some kind of transaction?
Right.
This is something that we are building with these basic terms, and we will create our meaning from these terms. And in this simple example, I created this special name. For example, send, but if you put this out prefix, then program will do something special, right? So from the perspective of language, it's okay. It's just another sense. So there is no difference. But in our evaluator, we can detect this. We can say, oh, someone put this send with this special name, and we will do something else. We will print this name to console. Why? This is our implementation, right? And this is how you can introduce some side effects, or what is the meaning of your program. Another like simple case, for example, transaction. Transaction can be that you can say, I was executing some program, and at the end, for example, this is our program. Sending something on A, sending something on B, receiving something on B, sending on B, sending this some special name, and then receiving on C. You can say if I have send and receive on B, this will be my transaction. Right, my account is B, and when I see send and receive together, this means that transaction is successful. Right, we don't have values here because we don't have enough state to record. But just for this case, we can say, yeah, but this have meaning of transaction. So okay, we are evaluating the program. There is no send receive on B. Yeah, the transaction happened. Right, we are interpreting some state how we want. We are saying, yeah, but the meaning of this is transaction. So this is how Rholang executes and changes the tuple space in a way that, oh, yeah, on this channel we are interpreting this as a volt, and if some value is on this channel, this will be our balance. Right, and if someone is sending something, we will increase the balance. If someone is, this kind of logic. So this is right on top of our language. but at the end, we are always asking, oh, what is the current state? What is in our set? And if we find something, we say, yeah, you know, this has this meaning. If we don't have, we have, oh, this have another meaning. But overall, we are just changing this internal state.
Got it. Okay.
And this is what this pattern we can apply to many things. I mean, if you are administering some server, you also have similar situation, right? You install something, or you know, you're changing the state, and then you want to observe it. Then you want to say, oh, is this, you know, is this process working? Is it responsive, right? So you have some operations that you can change the state of the machine, and you have some operations to observe it. And this interplay is really the language that you have. But usually we don't think about in the language terms, but this is exactly what we are doing. We are talking to our machine, you know, oh, install this, you know, try to connect to this, but we are always have this state, sometimes explicit, sometimes implicit, but we have this state. For example, when you install software, you don't have a way to directly change the files. I mean, you don't want to do it, right? You want some kind of interface, some package manager that you can say, oh, please install everything what is necessary, because I don't want to think about it, right? So you have some language that, you know, is doing this for you. You know, it will change the state in a way that you know it's correct, and you know.
Right.
So basically, this part is like a machine, and this set is the whole state of machine. And you know, we have send and receive to say, you know, oh, do this, do this, do this. You know? So somewhere in the machine is the interpreter which will say, oh, someone wants to install this. Okay, so we will execute this command.
So just to you know, understand the last 2-3 sentences that you just said about changing the state is the send operation, and observing the machine state is the receive process.
They are both, in a sense, they are both the same. Okay. Right? So if you just look at these two functions, you can say, but they are completely the same, and they are. One creates a send class and one creates a receive. So just by that, we are not saying the meaning. The meaning is when we are executing the program. This is when we are putting some meaning, right? We are saying, yeah, okay, now we will process the whole state. We will go one by one, each process in our set. So starting from empty, we will build the new set. And now we are processing one by one. Send with this. Do we have receive with the same name? Yes, do this. No, do this. Right? We are now processing this state. We are now giving the meaning what is inside. And in this example, the meaning is, if you have send receive with the two name, we will just erase it from the state, like it's never been there. And that's our whole program. It's just this simple.
Okay, all right, that helps somewhat settle down the multiple sort of confusions and unknowns in my head right now. So that helps. Okay, thank you.
Basically, it's simpler than it looks, right? it's just, oh, you are operating on the set. You are adding elements to the set and then removing elements to the set. Yeah, that's the whole thing. But we are creating this language so we can be very specific. You know, how the elements in the set are changed, how they are collected, how they are removed. We want to be very specific, and we want to create this operation so we can say to our users, yeah, but you can change this internal state. You don't need to think about that. We will do this, in the background. but we have these nice operations, and this our language is super cool. You can do lots of stuff.
So the just is there any documentation or which goes a little more detail into the language itself? I mean, has that attempt been made yet, just to compile a documentation around it, or do you have to just sort of like read the source code in a sense to understand?
You're talking about from the perspective of some real language, or this kind of way, right?
Well, I'm saying if I wanted to read a little more about Rholang and drill further down, is there any comprehensive documentation for it yet?
Something that yeah, I'm not sure right now.
Right. So for example, just say if there is somebody who comes into the project and wants to learn Rholang, I mean, they can certainly watch these video series which are helpful. But is there anything written down and say, okay, this is the overall what the language architecture is the syntax, these are the some of the examples of usage of the language. So just as a tutorial, basically.
Yeah, I mean, Greg created lots of different types of explanations, and so first I want to ask you, is this the documentation that you are asking about how to use Rholang, or more in a direction how Rholang is implemented, how this all of this stuff is working inside, and what is your main goal?
I think first part, which is to use the Rholang to, let's say, write the smart contract, right? I mean, to write the contracts themselves. So
yeah, we have something in the repository. What is the latest? So this is, for example, for just for matching, pattern matching.
Okay.
And this is the whole tutorial by Mike Stay.
Right. Yeah, maybe if you can maybe put that in your on the learning channel, link to that. And so this is the usage of the Rholang, and the second part you mentioned is how the Rholang is implemented, right?
No. The second part is more in details how matching works inside Rholang.
No. I meant earlier when I asked originally the question about if there's a tutorial, you said there were two. What are you interested in? Are you interested in how to use the Rholang, or how Rholang is implemented? Right. This is how to use the Rholang. And do we have anything about how the Rholang is implemented as well?
Yeah, this is maybe an even larger topic, right? So very good introduction in the, because implementing Rholang is using more than one some specific technique or so Greg developed this with many things in mind. So in the introduction to design of computational calculi, he explains more deeper source from where this is coming. Because implementation of Rholang, Greg says that this is one of many possible use cases for this whole thing that he's explaining. Also, this operational semantics in logical form. This can be used in many for many languages, and Rholang is like the first the first incarnation of using this as a also as a way to show how all of this can be done. And what I'm showing is somehow how can we use this knowledge in our current languages. Not just to implement Rholang. Rholang is here as an example, something that we are familiar. But I would like to create another language that we are doing some different thing, right? We don't have PAR, we don't have send receive, we have something else. But we still want to have this logic of we have state, we have operations. So now we are implementing our logic to operate on state.
So at this point, I mean, do we feel the Rholang? I mean, I understand what you're saying about having another incarnation, which might be a little bit more easier to consume for developers who have already have some experiences in other languages, for example, right? But I'm just curious, the Rholang as it stands today, I mean, how confident or how mature do you think the language is? Where, I mean, are we running into any issues, any bugs, any changes in the language itself, implementation of it at this point?
Yeah, I mean, we are definitely on the beginning. So now we are lacking some. For example, one important thing is with Rholang 1.1, so we can write sequential programs in more optimized way. So this is, for example, one important thing. But I want to say something more important, and this is something that I would like to show in these sessions. Writing concurrent programs in current languages, like with functions. Eventually, when you find out nice solution to write this kind of programs, this solution will be very similar to Rholang. That's the important thing. So you must discover Rholang. This is like a strange to say, but nice solution will be look like Rholang. When you doing something in parallel, and then you're doing something sequential, and then especially if you have this linear type that you consume some resources that you want to track, and even with functions, your writing your code will be very similar to Rholang if it is optimized. If it is not like spaghetti and
right.
No one knows how this works.
Right.
And this is what I want to show how let me see, I should have this here. Last finalized state block. What I missed. Sorry, why I don't have it here. I'm on different branch. Okay, maybe I should do this for next time. Yeah, I wanted to show in Scala using FS2 stream library how using queues this code is more elegant to write, but it's also very looks more like Rholang, when we have like something like channels and we are receiving something and then processing something, and we combining these streams and running in parallel. So this looks in a sense like Rholang. Yeah, I will show this in next sessions.
Right.
Yeah, but yeah, please.
No, I was going to ask. I mean, so yeah, I'm sorry, I didn't mean to sort of like sidetrack you, but this is the eval process is what you wanted to go through at the end of this tutorial.
Yeah, I mean, this is our implementation of our language. This is an interpreter.
Right.
And you can think of interpreter as something that whatever you have in your state, you can do some external actions, right? You can interpret, you can have different interpreter for the same language. And you can say, yeah, but this has meaning different than this other meaning, right? You can, whatever you are combining here in send and receive, how you will interpret these names. Maybe you can say these names are files, and when I have send or receive with the same file name, I will delete this file. This is my interpretation of this language.
Right. Got it. Okay.
And this is how you develop applications, right? You have small in the language for this, small in the language for that, and you interpret this in a way that how you want. You're really passing data around, and you're saying, when I see this data, I will do something, and that's it.
All right, so this is at least makes it a little bit clearer for me. Okay, thank you.
Cool. And basically, this technique can be used in any language, right? You just need interfaces, classes. In some languages, you can do more nice thing with these infix functions and this kind of stuff, or you can model effects in more nice way, and because you can say, yeah, but you are calling this print to the console directly. Oh, this is like the worst thing you can do. This is like effect, and yeah, I mean, yeah, whatever language you have on your disposal or abstraction, you can now implement and say, yeah. So in our code, we would create like a special F type here, and we will say, yeah, but we have something that is like a console, and now here we will call a console print line, So everybody's happy because now there is no magic, because this is a normal parameter to our function, and we are calling this print line, and everybody's happy. This is pure function.
Okay.
But we're still using the same logic of how we interpret our language.
Yeah. All right. I mean, this is good. I mean, I'm not sure if you have more stuff, or do you want to continue next week?
Yeah, we are over the hour, so yeah, we can continue next week. Yeah. So I don't have like a specific plan, so I really appreciate your questions. I'm really happy that you asked all of this. Yeah, thank you.